When you step outside on a clear night and look up, the sky feels infinite, a glowing ceiling draped over our home. But every star you can see with the naked eye is located in one tiny, highly localized neighborhood of our Milky Way galaxy. That sprawling blanket of stars is a single drop in the cosmic ocean. To understand our actual place in reality, we have to leave the surface. The moment we punch through the atmosphere and enter low orbit, we hit the first boundary of human reach. Suspended 400 kilometers above the ground is the International Space Station, the largest structure human beings have built in the void. It currently tears around our planet at over 27,000 kilometers per hour. If we jump 400,000 kilometers further out, we hit a hard stop. The desolate, rocky surface of the moon marks the absolute furthest physical boundary that human beings have ever walked upon. Because the moon lacks an atmosphere, there was no wind or rain to scrub away history. The footprints left by Neil Armstrong and his fellow astronauts remain perfectly preserved in the lunar dust, freezing our greatest travel achievement in time. Standing on that gray rock and looking back, the Earth shrinks to a fragile, finite marble. The illusion of our world as a boundless, all-encompassing reality shatters. Pushing past the moon, the scale of our neighborhood rapidly escalates. We pass Venus, choked by clouds of sulfuric acid and a runaway greenhouse effect, and Mercury, a battered rock where temperatures swing by hundreds of degrees between day and night. Moving outward past Earth, we hit Mars. Today, it is a dead red expanse of dust, but ancient dried riverbeds suggest a watery past, making it the most likely candidate for our next attempt at colonization. Earth's geology feels impressive until you look down at the Martian surface. This is Olympus Mons. It is a single ancient volcano 3 times taller than Mount Everest. Our planet's greatest geological features are dwarfed by the architecture of our neighbors. Controlling all of this is our Sun. Sitting 150 million kilometers away from Earth, its mass and violent thermal energy serve as the gravitational anchor, dictating the orbital mechanics of the entire inner system. Beyond Mars lies the asteroid belt, a vast, churning ring of raw planetary rubble. These massive rocks could have clumped together to form another world, but they were overpowered by a single immense force further out in the dark: Jupiter. Its gravity is so intense it stunted the growth of planets around it. As a gas giant, it lacks a solid surface. Instead, it is a sphere of swirling storms. The Great Red Spot is a single hurricane large enough to swallow multiple Earths. In this landscape of giants, Earth stands as a quiet biological anomaly within a system defined by mass and violence. Further out, we reach Saturn, defined by a sprawling, intricate ring system of ice and rock stretching hundreds of thousands of kilometers across the black sky. Orbiting within those rings is Titan. It has a thick atmosphere, clouds, and functioning weather systems. But at temperatures deeply below freezing, the lakes and rivers carving through its surface flow with liquid natural gas instead of water. We accelerate past the ice giants, Uranus and Neptune, and cross into the Kuiper Belt. This massive frozen debris ring is 20 times wider than the asteroid belt, redefining the actual perimeter of our planetary system. Deep inside this frozen ring is Pluto. Stripped of its major planetary status, it exists out here as a dwarf planet shaped by mountains of water ice and extreme isolation. 19 billion kilometers from Earth, we finally catch up to Voyager 1. Flying faster than a bullet, this small probe is the absolute furthest limit of human-made objects in the void. It is completely alone. Eventually, even the sun's gravity fades. Surrounding our entire system is the Oort cloud, a theoretical shell of icy comets. This marks the final fading edge of the sun's influence before the true interstellar void begins. Everything humanity has ever mapped, walked on, or sent probes to is just a tiny, gravitationally bound ice bubble drifting through a much larger, darker cosmic ocean. We cross that dark ocean to the Alpha Centauri system, our closest stellar neighbor. It is so far away that light from our sun takes over 4 years just to reach it. When we pull back far enough to see our entire home galaxy, the Milky Way, the scale breaks. This spiraling structure of hundreds of billions of stars is roughly 100,000 light-years across. Zooming out, the Milky Way shrinks to a dot, joining the local group. This cluster then compresses into a tiny patch within the massive Virgo supercluster. Finally, Virgo becomes just one node in the colossal Laniakea Supercluster, stretching across 520 million light-years. At this cosmic scale, entire galaxies containing billions of stars are reduced to grains of sand. Physical distance out here exceeds our biological capacity to visualize space. Our brains are simply not wired to process voids this large. Pulling back beyond the Laniakea Supercluster, we finally hit a hard physical wall, the edge of the observable universe. This boundary represents the absolute limit of light that has reached our telescopes in the 13.8 billion years since the universe began. This glowing sphere of ancient light contains everything we know. Yet scientists pose a terrifying mathematical concept, the multiverse. Our entire observable universe could merely be a single microscopic drop of water in an infinite rolling sea of other expanding universes. Humanity currently possesses no physical probe, no advanced telescope, and no definitive mathematical equation capable of piercing this horizon to verify what lies in the darkness beyond the light. We occupy a microscopic coordinate on a wet rock orbiting an average star. Yet, while the physical universe is vast and silent, our biology has produced the only force capable of measuring it. In this calculation, our physical insignificance is balanced by our unique ability to perceive the scale, a tiny blue rock that finally gave the universe a way to see itself.